Thank you, Eric. Hi, everyone. I'm Bozi, a principal data scientist in Genentech Roche. So I'm happy to share our project leveraging large language model to develop R code for the output delivery. Okay. So this is just a general disclaimer to say all the data we show in this presentation are dummy data or published. And the first question, why we want to have this effort? So as you may know, so like in the pharma, like in Roche or some other pharmas, so thousands of TLGs, I mean table, listing, graph, like something I show below, so are delivered each year for internal readout, for filing, for publication, and the overall this process still manual. So that means still labor intensive and time consuming. And on the other aspect, Roche is having a transition from commercial software to R for the clinical trial TLG delivery. We are trying to use the table engine R tables and 10. A part of our team members, they are new to the R, let alone the R tables and 10. So that means there will be a steep learning curve. And also you can imagine at the initial transition stage, we may not have the high level of efficiency as before. So we are wondering whether we can have some solution like leveraging like the chat GPT or something to assist the transition to make it smooth. And also more important, in the long-term run, can we boost the performance in the TLG delivery to reduce the time and the effort. And so these are the big picture what we want to achieve, but what's the use case we are currently consider. So this one, so first, we want to answer users' basic question regarding the functionality and arguments of our tables and term, like what's the function this for and which option are available for an argument. And also, we hope can assist users to modify their code to get the desired tables or plot through natural language prompts. So here showing like an example of our tables and 10 code to generate a demographic table on the right. So we hope like this tool can help the user to understand so each function, what it stands for, and how to use that, and how to meet like the team's requests, maybe like changing the removing one row, adding one row, or changing some calculation. In the next several slides, I will have a quick review about the method and materials we use for proof of concept experiments. So first, here we are using the GPT4 Code Interpreter and Azure GPT4 API. You can see the red part showing a screen copy of the Chat GPT. So as long if you tick the advanced data analyst beta feature, so now you are using the Code Interpreter. And why did we choose this? Because in this beta feature allows you to upload the file you want. You can see I already put one like a code template zip file here as an example. And then the other three are the materials we are going to provide to the ChatGPT. So the code templates here I show a basic version of a demographic table. Here it kind of serves as a starting point where user can modify from, and also the function manuals of our tables and the 10. So that's the function manual you can find from the PDF long 700 pages like the from the Chrome the package menu, and then we just you show the what we have an example, and also we have the variable dictionary. So that's two column, one column for the variable ID, one column for the variable like a label. So in this one, we were trying to see whether ChatGPT can find the variable we want to use just based on like a natural language description. And here has the high-level summary of our POC experiments. So the code interpreter has a good performance if there are related information in the code template or in the from the function manuals in the beginning task, in the following task. So based on our requirement, so it can select the code template and also can select and suggest a variable to use and add codes to process and filter data. More important, it can modify the codes to update the TLG layout and the content. Let me show you one example. This is the demo I created for this conference. So you can see when the chat box starting with blue, so with a blue box, that means that my question or my prompts, and the one starting with the purple one means that's what returned by the chat GPT. Here I uploaded 3 files. One is the zip file of the function menu, one is the zip file of the template codes, and one vector dictionary. My first task is I told the program ChatGPT I want to draw a KM plot. Can you please suggest one template? And then it search in the template folder and tell me he found one good match, Kaplan-Meier plot text file, and I ask it to show me the code. So you can see this code within this file. So it's very basic. Next, I will demonstrate how the ChatGPT can modify the code. I will ask it to do some task using some arguments not showing in this basic code. So first, ask, I want to add color to the curves. One is green, one is red, and then it will check the menu of the GKM function and add the arguments color here. And you may see the color argument is very common in almost the same in the different functions it can guess. So then let's try some like a GKM specific arguments. So then I ask, so I want to add annotation table to the plot. So like the risk table or like the survival median time table. And then also still the ChatGPT will search into the menu and say it found 3 arguments can control to show the table or not. And they say also detect one where one table already set to true in my basic code and ask me whether to set to true for the other controller arguments. And I say yes. Then you can see it already added 2 arguments here to show the annotation table. And then I will ask, so can you modify the location of the table? Because usually the team member will ask, oh, move the table to this corner or that corner. So in this one, I ask to change the location. Can you teach me how to modify the location of the tables? And then of course, and then he says found another 2 arguments, the position cox and the position thermite. So you can see it showing like the position or the just position of 2 annotation table. And in the next, I want to demonstrate how the capability of using ChatGPT to searching the variables and adding codes to modify the dataset. Here I say, I want to subset the patient before running the code above. So I want to select the patient who are safety evaluable and enrolled in the study before certain date. And then it will search in the variable dictionary. And here quickly he will find like 2 variables, safety population flag and the date of enrollment. Then it will show the code here to do the using the basic R to do the filtering. Okay. And in the meanwhile, we also develop Azure GPT4 API-based chatbot. So in this way, users do not need to upload the files themselves every time. And also we have more freedom on how to prioritize the materials provided. So I think I already ran out of time, so I don't have time to run a live demo. So, but this are kind of uh, screen copy of our current chatbot. And also for our next steps, we want to boost our chatbot's performance through providing more curated materials and also improve the speed. If I show the demo, you will see that currently still the speed is slow. And also we are trying to implement a feedback collection system to know how satisfied the user about the performance. And also they can provide the free text comments for more detail. And and I want to thank for our team member Vincent, JV, and Mingyi, and also Jian is our external team technical support, and also Ning and James for the sponsor. Thank you.
My goodness, Bo, that was an amazing talk. And I think many of us are just beginning our journeys of leveraging large language models and AI to help with our day to day statistical deliverables. And I think this is going to be an excellent jumpstart for many of us to be inspired of what is possible. So I'm very appreciative of seeing this. So thank you so much. We don't have time for questions, but certainly if you can stick around in the chat on the main stage. I think you're going to be getting some quite shortly, if not already. So, yeah, thank you again, Bo, for the great presentation.